Good morning, students. Welcome to Bindu Dhadwal Chemistry Lessons. Our topic for today is directive influence of a functional group in monosubstituted benzene. So, when a monosubstituted benzene is further subjected to substitution, three possible isomers can be formed, but they are not formed in equal amounts: ortho, para, and meta. If the isomers formed are ortho and para, the functional group or substituent is said to be ortho-para directing substituent. And if the meta product is formed, then the substituent is called, or the functional group is called, meta substituting. So two types of behavior are observed. These behavior depend on the functional group and not on the entering group. So this functional group may be either ortho and para directing or meta directing. Behavior depends upon the substituent already present on the benzene ring and not on the entering nature of entering group. This is known as directive influence of substituents. Reasons for ortho and para or meta directing nature of groups. So let us take the example of ortho and para directing group, hydroxy group. So the groups which direct the incoming group to ortho and para positions are called ortho and para directing groups. For example, OH group, the lone pair of electrons on oxygen atom enter into conjugation with the electrons of benzene ring, as a result of which the following resonating structures develop. These lone pair electrons move here. As a result, the pi electrons move to next carbon atom and a negative charge resides here in the next structure. A double bond comes here, positive charge on this oxygen atom and a negative charge here. To form the next structure, the electrons will move here and these electrons will come to this carbon atom and a negative charge comes on the para position. In the next structure, these electrons move here, these to the next carbon atom, and a negative charge comes on the ortho position with respect to OH group. Then when these electrons move here and these electrons go back to the oxygen atom, another resonating structure develops. So we see that out of the 5 structures, 3 of the structures have a positive charge on oxygen atom and the negative charge will come on either ortho and para or again on ortho position. So it's clear from the above structures that a positively charged electrophile will approach the sites of negative charges, that is ortho and para position. So substitution takes place mainly at these positions. However, it may be noticed that OH group otherwise has a electron withdrawing influence. It has a minus I effect. So the electron density is slightly reduced on the ortho and para position, but the overall electron density increases at ortho and para positions due to resonance. So OH activates the benzene ring for an electrophile. So these groups are called activating groups. Other such examples of activating groups are amino groups, NHR, that is secondary amino, and NHCOCH3, that is N-acetyl amino group. Methoxy group is also electron releasing in nature, so ortho para directing. Methyl group is ortho para directing. Alkyl groups, ethyl group, are ortho para directing. In case of aryl halides, the halogens are moderately deactivating because of strong minus I effect. Inductive effect is electron withdrawing in nature. But Because of resonance, the electrons enter into conjugation and increase the electron density at ortho and para positions. Negative charge resides in the ortho and para and ortho positions in the resonating structures. So they are also ortho and para directing group. Resonating structures of chlorobenzenes are shown below. Because of stronger electron withdrawing influence, these are less reactive as compared to phenols. The groups which direct the incoming group to meta position are called meta-directing group. Nitro, cyano, aldehydic, ketonic, carboxylic acid, ester, and sulfonic acid groups all are meta-directing in nature. For example, nitro group is a resonance hybrid of following structures. The oxygen being more electronegative attract the shared pair of pi electron towards itself, resulting in a deficiency of electrons on nitrogen atom. So it takes the electrons of the benzene ring, thereby resulting in a positive charge on ortho and para positions. In the next structure, these electrons move here and positive charge comes here in para position. When these electrons move here, positive charge comes on ortho position. So its electron withdrawing in nature shows minus I effect, as well as because of resonance also the positive charge resides on ortho para position. So overall electron density on benzene ring decreases. Substitution becomes difficult. So these groups are called deactivating groups. The electron density on ortho and para position is comparatively less than at meta position because there is no positive charge on meta position in these structures. So meta position being more electron rich, the electrophile will approach the meta position and substitution will result there. So nitro group and other such groups are meta-directing in nature. Carcinogenicity and toxicity. Benzene and polynuclear hydrocarbons containing more than 2 benzene rings are fused together and are toxic. They have cancer-producing carcinogenic properties. Such polynuclear hydrocarbons are formed on incomplete combustion of organic materials like tobacco, coal, and petroleum. They enter into human body and undergo various biochemical reactions and finally destruct, damage DNA and cause cancer. Some of the carcinogenic hydrocarbons are 1,2-benz-anthracene, 3-methyl coal-anthracene, 1,2-benz-pyrene, 1,2,5,6-dibenz-anthracene, 9,10-dimethyl 1,2-benz-anthracene. All these are polynuclear and carcinogenic compounds. That is all in today's video. If you like the video, please do share and subscribe. Thank you. Have a nice day.